Hi everyone, this is Babar Shehzad and today I'm going to demo my dissertation project QoS Dependency Aware Services Offloading in Edge Computing. So this is the agenda of my project. Introduction. So these days IoT devices and real-time application require faster processing and they generate huge amount of data to be processed. However, these devices are uh, resource constrained, meaning they have limited computational power, and that makes it really difficult to process these tasks locally. So these insufficient resources can lead to performance degradation and can affect overall QoS quality of service of real-time applications such as online gaming. So one proposed solution is to execute and offload these applications to cloud server, but typically these cloud servers are geographically distant from uh, end devices, so these can introduce the communication latency. So in that case, edge computing provides the solution. What is edge computing? Edge computing basically is a distributed computing model that brings computation and storage closer to the data sources and applications. And in the context of task offloading, it refers to transferring the computational task from resource constrained IoT devices to more capable edge servers. So these offloading these application to these best suited edge server with sufficient resource can improve the quality of service by reducing the communication latency as compared to cloud computing. So there are quite a few existing research work. Mostly, many researchers have worked on multi-tier architecture where they have explored the collaboration of different architecture like cloud computing, edge computing, and devices layer for task offloading. In the QoS aware task offloading, the researchers have worked on improving different matrices, performance matrices like energy consumption, execution time, and network usage. For in the reinforcement learning approaches, in this machine learning methods, researchers have researched on the adaptive methods for real-time task offloading in a dynamic environment. So the research gap, if you look into the existing research, most research look into offloading the task randomly to different edge servers without considering the communication between the dependent tasks. Addressing addressing this gain can potential we can gain potential performance gain. So we have proposed a solution, affinity service rule algorithm. So basically, the what the offloading and our offloading algorithm optimizes the task allocation across edge services servers by considering the task dependency and resources availability. So our algorithm assess the resources and compares these resources with the edge server available resource for optimal offloading. So the algorithm offloads the dependent task to the same edge server to reduce the communication costs and latency. So here's the algorithm workflow. There are multiple applications. First, algorithm assess the resources assesses the resources requirement of dependent application, and then it checks for the best available edge server for task offloading. If there are some other tasks are already running there, algorithm tries to migrate those tasks to some other edge server. Then it maps dependent application to some best suited server and then offloads the task to some to that server. Here we can see that it has uploaded task to some server, and dependent application 3 and 4 are deployed to the edge server 3. implementation part. So here we can see some pseudocode of our algorithm where we the if it first creates a task list and iterate over the task and checks if the task is not dependent, compare the resources requirement with the edge server edge server resource in terms of MIPS, RAM and bandwidth. If a server is found, offload the task there and update the remaining tasks of the edge server and remove that task from the list. And if the task is dependent, it calculates the required resources of those tasks and compare those with the available resources of edge servers. If there are some tasks already deployed on some server, it migrates the task to accommodate the dependent tasks first and offloads the dependent task to that server. At the end, if the algorithm could not find any edge server with sufficient resource, it will offload the task to the cloud. So let's quickly look into the code side. So this code side implementation is done in Java programming language and iFox simulator. iFox simulator basically provides the simulation for creating uh, edge environment uh, in a simulation environment, in a controlled environment. So here we can see we can create multiple applications in the iFox sim, and we can define multiple modules of each application with different resources requirements. So we can modify, increase and decrease and these resources requirement like RAM and MIPS and also the bandwidth. And again along with that we can also create the fork devices as well. We can see we can create fork devices in iFox simulator. We can give it a name and resources which it can have like MIPS, RAMs and bandwidth. And next what we do is we call the algorithm to offload tasks. So similar to the pseudocode I have shown previously, it first checks if the task is dependent, it deploys the tasks without checking for dependency, and only checks for the resource requirement. If the task is dependent, it performs certain steps like grouping the tasks and calculating the task resources requirement and check if the server is available with sufficient resources. If it is available, offload the task. If the task is not uploaded there, uh, we check for total resources of that edge servers in here. So if it the algorithm could can find that specific edge server, it will offload the dependent application over there. Otherwise what it will do is it will migrate the existing independent task from that server. Here you can see we are calculating and checking if there is any task already deployed on that resource. We migrate the task from there and get back the resources, and once the resources are available we migrate the dependent task over there, and those independent tasks we have migrated from there, we offloaded them to some other available edge server. So if we go back to the main file, at the end when we have mapped all the edge server to the task to the edge server, the iFox sim, in iFox sim we can submit the application for simulation. So if I run the application, So it will generate a few results based on the our offloading. So here we can see the output that the data application is offloaded to fork devices, fork device 1, and camera and image processing applications which are dependent were offloaded to fork devices 3. And we can see few other results as well, like execution time, application loop delays, and uh, execution delay. If you can see that we have a couple of matrices, like in term of network usage, we can see the dependent applications are deployed on the same server, so it didn't consume any network resource. And in terms of energy consumption, we can see it had consumed this amount of energy. So going back to the result section, we can see our proposed algorithm performed better than the other approaches I have tested with, like hybrid approach, where we deploy that offload the task to cloud and the edge server, and the cloud centric approach where all tasks are offloaded to the cloud. In execution time, it has performed better than the other two approaches. In the application loop delay, the proposed algorithm also performed better or similar to the hybrid approach and far better than cloud approach. And this network usage, we can see that after deploying or offloading the dependent application to the same edge server, it didn't use any network resources. And in the the energy consumption, we can see that the edge servers are typically lightweight, so it consumes far less energy than typical cloud server. So talking about the research finding, as we have seen that the proposed algorithm demonstrated a significant improvement across different performance matrices, including the execution time, communication latency, network usage, and energy consumption. For limitation part, we can see that these experiments were performed in a controlled environment of iFox simulator. So in real world, these can be different result we can see. So in the future work, we would like to integrate this task offloading algorithm with some cloud native orchestration tool like Kubernetes or cloud native uh, tool. So this would really help us to view the algorithm performance in real world environment for, to see how it performs actually in the real world applications. So that's it from my side. Thank you.